Yeah, so in terms of sequences and series, right? We usually have to just take care of what the question wants from us and to identify the type of sequence we're talking about. So here we're given a quadratic. They want Tn number one, which is the nth term of the quadratic sequence. So for 2.1.1, we can say, okay, since we have the sequence 100 there, you have 120, 132, and luckily enough they already told us, so we know that we are going to be looking out for the second difference there.
Yeah. That's what we're gonna do.
Yes. So we say 100 minus 72. I think that should give us what? Is it 28? Right. And then 120 minus 100, that should give us 20, right? Then 132 minus 120, I think that should give us 12. And then when you say 20, wait.
It's
Okay.
gonna be -8.
Yeah, it's going to be negative, right? -8, because 20 minus this is going to be negative. Remember, we say right minus left all the time. Right minus left. Okay. Then 12 minus 20, that should give us -8. So therefore, we know that we can just plug in 2a is equal to this, 3a plus b is equal to that, then a plus b plus c will be equal to that. So therefore we say 2a is equal to -8. That should give us our a to be -4, right? Then 3a, meaning 3 into -4 plus b is 28, which will mean -12 plus b is 28, and therefore b should be 28 plus 12, making our b to be 40. Ne?
Yes.
Right. Then remember, a plus b plus c is 72. So that tells you that -4 plus 40 plus c is equal to 72. Which means 36 plus c will be 72. Therefore our c will be 72 minus 36. Right, so 72 minus 30 there should be 42, minus 6 should be 36. Is it 36?
Yes, it stays as 36.
All right, great. And then now therefore, remember, for a quadratic sequence, you have Tn as an squared plus bn plus c, which is a parabola. So therefore we have -4n squared plus 40n, and then plus 36. Then 2.1.2, right? They then says a term in this quadratic sequence is equal to the 12th term of the sequence of first differences. Is equal to the 12th term of the sequence of the first differences. Determine the position of this term in the quadratic sequence. Right, so what they are talking there, right?
Sorry, please can you repeat that?
It says we have a term, right, in that quadratic sequence here, which is equal to the 12th term of the sequence of first differences, right? That statement there, it sounds a bit too much and confusing. However, we can break it down into the following. First of all, we have a term in that quadratic sequence which tells us that we're talking about Tn is equal to -4n squared plus 40n plus 36. This is for the quadratic sequence, right? Then now that term, right? So that Tn which is this. It's equal, right? So let me try to bring this down if possible. Ooh, oh yeah.
Taking the nth term from the previous question.
Yes, because they said a term in the quadratic sequence. Remember, this is the quadratic sequence we were working with, right? Yeah, this is the one here. So they are saying a certain term in that sequence there is going to be equal to the 12th term of the sequence of first differences. So which means that if I can maybe try to do this, is 100 and then 120, 132. Now it goes on and on. Then there is a term here, right? There is a certain term. I'll just call it Tn, right? There's a certain term of which now, yes, there will be others. However, this term, it's equal to the 12th term of the sequence of first differences. Now our first differences, remember, is 28, is 20, is 12. These first differences, they continue in that way, right? They continue like that, and then you find that at position 12, right, of these first differences, at position 12, 12th position, you have a certain term, and that term is equal to this to the one in the quadratic sequence. Do you see what's happening there?
A bit. I'm not seeing the full picture, but I'm getting there.
Okay. All right. So let's say, first of all, let's try to find that term in the first differences, right? In the sequence formed by the first differences. Let's remember that here, these are our first differences. Just write first differences, right? In that first differences, we have the 12th term. Let's find that 12th term. So first of all, we need to find the general term of this. Usually, because now it's -80, it's -8. The first differences, they always make an arithmetic sequence. You see, remember, the main number pattern or the main sequence is quadratic. The first differences, they actually make an arithmetic sequence all the time. Okay, so since they make an arithmetic sequence, we can actually use Tn is equals to a plus n minus 1d.
Sorry to disturb you. The second, or is it the third difference that makes an arithmetic sequence?
Is the first differences. These first differences.
Okay, that's it.
The second difference is always constant for a quadratic. It's -8. It's constant. Yeah. And a way to look at it, I always say, look at it this way. If I have a parabola, for example, I can take any random equation. Let me just take maybe 2x squared minus 3x plus 6 as my f of x. Is that okay?
Yeah.
When you differentiate this, you get 4x minus 3. What type of graph is this?
Isn't it a straight line?
It's a straight line, right? And a straight line corresponds to an arithmetic sequence. You understand me?
Yeah.
Yes. And then if you differentiate this further to find the second derivative, what do you get? You get 4, right? You get a number that is just constant. I get. Yeah, then that will be your second difference. You see? Yeah, so this is just a way, right, to just say think of the flow of these sequences, to say from quadratic, arithmetic, and then just a constant difference. Relate that a bit just to calculus, but we are not on calculus, and we shall continue then. All right, so that is what is happening there. So the first differences make an arithmetic. Now since they make an arithmetic, we're told about T12, isn't it, to say that you have the 12th term of the first differences. You see, it says the 12th term of the sequence here, the 12th term of the sequence of first differences, which means we're talking about T12, right? T12 will be equal to the first term, which is 28, plus n, remember n is 12, right? And then d, right, the difference, we know that it's negative 8. So what will be that T12? (11 into negative 8). So we get, is it negative 60?
Give me a minute, please. Just want to confirm.
No problem.
Yeah, negative 60.
Perfect. Now that is the 12th term of the first differences. I'm just going to write here negative 60 to say it's one of the first differences. Now what is so special about it? They told us that a term in the quadratic is equal to that 12th term, meaning that there is a certain term here in the quadratic which is equal to that 12th term of the first differences. You understand me? Which means that we're going to say negative 60 is equal to negative 4n squared plus 40n plus 36. This means that as you go along the quadratic, there is actually a negative 60 here. We just don't know its position. You understand me?
Yeah. So basically, from my understanding, you use the arithmetic method. So what you did from it, did you found the what do you call this?
The term. The term.
Yeah, but like the fx thing.
Fx. No. That, like I didn't want you to take it in terms of calculus. I was just saying that the flow of things, or the order of things, that you have a quadratic sequence whereby its first differences, it's an arithmetic sequence, and then whereby the last the second differences is just a constant number. That's what I wanted to emphasize. Okay.
Oh, so from my understanding, you used arithmetic sequence for the first
difference
to be able to find the value. So you took so you used the first difference line. So 28 was the first term. Then where did the 12 come from? You said it come from
the position. It's T12, yeah.
The position. The negative 8 was the difference between them. Okay. And then you found the value of negative 60. Okay. Then why are you equating it to the general formula of the whole thing? I can ask you.
It's because now the instruction, right? The instruction said 2.1.2, read it. It says a term in the quadratic sequence is equal to the 12th term of the sequence of the first difference.
Okay.
Meaning that in the quadratic there is a certain term which is...
So in order to find the term, you have to equate them together, because it's equal to the value that we got from the first difference.
Yes.
Okay. I know, I understand. Continue.
Great. So from there, that is when now after substituting into the original, right, because we got the term, we do not know the position. We do know that there is a negative 60 here on the quadratic sequence, but we don't know at which position. Okay, so now we're going to look for that position. because the question said determine the position. You see what the question said? Determine the position of this term in the quadratic sequence. Okay, so that's what we
So
are
the
looking.
term of what T, they want the term of T12, then?
No,
The first difference, then?
no, the 12th term of the first difference is negative 60. Ne?
Yeah.
Yeah, we are told that that first term it's equal to one of the terms in the quadratic.
Okay.
Right, to one of the terms in the quadratic. So it means that since we got that the 12th term in the first differences is negative 60, it means in the quadratic sequence there is a negative 60 somewhere. There is a term that is equal to negative 60. We just don't know its position. So that is why we equate here to say Tn. Remember, Tn is the term. We say it's negative 60, but we do not know the position. So to solve for the position, you can take the 4n squared this side, and then have the negative 40n this side, and then say negative 60 minus 36. So that should give you 4n squared minus 40n, and then I think minus 96 there. Then from there you can solve for the position. I think we can try to just divide if possible. And 96 divided by 4 is what? It's 24. Okay, so essentially you have n squared minus 10n, and then minus 24. So you can use the quadratic formula when you are here, or you can simply try to factorize. You have n, 12 and 2, right? Then negative 12 plus 2, then equal to 0. So your n will either be negative 2 or your n will be 12. But remember, the position can be negative, so therefore the n will be 12. Okay, right, so it means this negative 60 is at position 12 in the quadratic. Yes. So that is what is happening there. And yeah. So to even illustrate that, right, maybe just a bit further to add more clarity on that question there, right? What we have is the following. We have a quadratic which is going in this way, whereby you have 72. So I'll just write here quadratic. Now you have 72, you have 100, you have 120, you have 132, and then this is 1 2 3 4 5 6 7 8 9 10 11 12, and then you have others there, 13. But at 12th position you actually have negative 60. You understand me? While the first difference is you have 28, which is 1, 20, which is on position 2, 12, which is on position 3, according to that first differences. I get right? Yeah, these are the first differences which form an arithmetic. So if you take them as a pattern, this is position 1, position 2, position 3, you have position 4, position 5, position 6, position 7, position 8, position 9, position 10, position 11, and then here you have position 12, whereby you have negative 60. 12th position, while this one is also on the 12th position. Do you see that? That's what we are saying when we are saying that when we are saying that a term in the quadratic is equal to the 12th term of the first differences. Right. I hope that is okay. And then we can go to functions, right? Just to deal with functions a bit. Maybe we might, I don't know. Okay, let's look at this one. Of which now this one, it says you have lines. These lines are axis of symmetry for the function f there, right? Show that p is equal to that and the likes. Now for 4.1, let's understand that if you have a hyperbolic function, right, its axis of symmetry, they always meet at a common point, and that common point actually determines the axis of the asymptotes. Now what I mean is this. This one, you can see there is a negative there. It means that that particular thingy is in the third quadrant. Is what is yeah, is in this quadrant and this quadrant. Yeah. So now the axis of symmetry, the lines of the axis of symmetry pass through each other like this. They meet at a common point. That common point has a coordinate x and y. That x and y determines the vertical and the horizontal asymptote. So now, since we are given the equations of the two lines, all we need to do is to find the point of intersection of the two lines. Then we have this coordinate. That is the most crucial coordinate that we need there. So you have y is equal to x plus 1, and then you have y is equal to negative x minus 7. You can just solve simultaneously by saying maybe y is equal to y, which means x plus y is equal to negative x minus 7. You just equate the two. Then from there you can say x plus x will be equal to negative 7 minus 1, which means 2x will be negative 8. Divide by 2, your x will be negative 4. Then to get y, you simply use one of the formulas to say negative 4 plus 1. Therefore, y is equal to negative 3. Therefore, this means that that coordinate I was talking about, it's actually negative 4 is to negative 3. Now, understand the following, that the equation of a hyperbola is like this. And then P is going to be the x of that point, but you change it. You would, yeah. So you're going to say x plus p is equal to that value there, which is the x coordinate, and then therefore, what does that mean? It means your p is what? Or rather, in simple ways, you can just simply say, therefore your equation will be y is equal to negative 2 all over x. You just change the sign. When it's on the formula, it's the different sign. And then this one, the q does not change the sign. You have minus 3. So from there, looking at the question, right, you can definitely see that your p there is what? Your p is 4, and then your q is negative 3 there. Right, what they wanted you to show them. So it was just a matter of knowing that this point is a point of intersection of your lines of symmetry. So the coordinates of that point give you the vertical and the horizontal asymptote, or give you the value of p and q on the hyperbola there. Then yeah, the rest is to get the x-intercept and sketch the graph, which is now fairly easy because now you have the full equation, right? So you have negative 2, you have y is equal to negative 2 all over x plus 4 minus 3. To get the x-intercept, right, just like what they wanted, remember that would be simply letting y be 0, then you will say 0 is equal to negative 2 over x plus 4. Right, take the 3 this side. Now we're just simply solving. Maybe do a bit of a cross multiplication there. Negative 2 will be 3x plus 12. Right, then you say negative 14 is equal to 3x. Then you divide by 3. So your x will be negative 14 over 3. Of which 14 over 3 is around 4,5. But so it's around 4,7. So that's 4.2 there. They just wanted that. And then the last question will be to sketch. Now when you sketch, just be careful of the value of a. Since your a is negative, since the a is negative, we draw the graph like this, and we start with the asymptotes. Again, this will be x, this will be y. Your asymptotes, if this is x plus 4, the vertical asymptote means it will be x is equals to negative 4, meaning that it will be this one here, negative 4 here. And then the horizontal asymptote goes on negative 3, means this will be the horizontal asymptote there. Then lastly will be to sketch the graph. It's going to be in this quadrant and this quadrant. Right, now you can show that. Now remember, you calculated the x-intercept, right? So here the coordinate should be negative 14 over 3 is to 0. And then here you can calculate the y-intercept by letting x be 0. That will be negative half minus 3, which means negative 3 and half. Negative half minus 3. Negative half minus 3, that will be negative 3,5. Yeah, so it means here it should be negative 3,5. Alright, so then you get your full marks there for sketching F. So the most crucial part was to determine this point. Remember, this point here, the coordinates of that point is negative 4 and negative 3. So this is the point whereby the asymptotes themselves, right? The asymptotes themselves, they pass through like this. So the asymptote will be passing through like this, or maybe let me draw them as lines to say this will be the first asymptote, this will be the second, axis of symmetry, right? This will be the second axis of symmetry. So the other one had the equation of y is equals to x plus 1, which is this one. And then the other one had the equation of y is equals to negative x minus 7, which is this one. Because it's decreasing, that one is increasing, one is a positive gradient. So yeah, this point they meet there is the one that allowed us to get P and Q. Any question from here? Alright, so try to go through it all over again, maybe just to then get an understanding of how we deal with those problems, right? Which will then assist with revision paper.